Hello and welcome to this repair tutorial, and today we're going to look at a Rotel. Model number is RA-02, and this is what we term as an integrated amplifier, meaning that the preamplifier and tone control circuits and also the power amplifier stages are all in one single unit. So this Rotel amplifier was launched in around 2002 and got some exceptionally good results in terms of performance compared to other brands. In terms of general specifications, we're looking at 40 watts per channel, and this is over the normal frequency range of 20 Hz to 20 kHz, and you're looking at 0.03% with an 8 ohm speaker load, and it does support dual speaker set output. So what we mean from there is that when you look from the front, you have the selection term speakers, and you can go off. So this is for personal listenings if you're going to connect a headphone socket. You also have speaker set A, speaker set B, or you can have both of them on at the same time, and these are independently switched relays inside the amplifier rather than just a mechanical switch. And then total harmonic distortion 20 Hz 20 kHz again, so again less than 0.03%, and that's rated at half power or 1 watt. And then we have a frequency response for the phono input stage and also for your line level inputs as well. And then your damping factor 20 to 20 kHz, and that's 8 ohms, which is 180. And then line input sensitivity is quite normal, so this is 160 millivolts with a 24k input impedance. And then you also have a preamplifier output as well, so that's rated at 1 volt, and then your impedance there would be 470 ohms. And then for your line input overload protection, that's 5 volts maximum. And this amplifier can have a moving magnet type input coming in from a record player, and that's a standard input sensitivity of 2.5 millivolts with a 47k ohm load. And then your maximum input for your phono is 150 millivolts. And then power input requirements for this amplifier, because it's UK, is 230 volts at 50 Hz, and overall power consumption is about 220 watts. Now, this is quite a sleek amplifier when you look at the front fascia and the overall size of the amp. So it has a width of 435 times by a height of 72, and then you have overall depth of 342 millimeters, and just the front panel height is approximately 60 millimeters. And it's quite lightweight, so net weight here is 5.9 kilograms. And although you can control, of course, the amplifier from the front fascia, you also have this remote control as well. So you have the small IR port, which is right in between the phono input socket, the headphone socket, sorry, and then also the speaker selection. And the model number there is RA-AT94. Now, as with all these remote controls, if you're unable to source, one of the original type remotes, then there's companies out there who can provide, copy remote controls, and they just simply have the IR codes built in. Now, I do like the design of the amplifier, and I've repaired a number of these over the years. When you look from a cosmetic point of view, it's a very clean layout, and what they've done is they've implemented these blue LEDs, which gives it a bit of a nice touch. So when you have the power selected, then that will illuminate, and they put a LED also wide back to the board inside for the volume control, so that's quite a nice feature. And then also as well for the input selection, be it phono, tuner, CD, aux 1 or aux 2, and it's common with the Rotel amplifiers. You also have this monitor switch as well, so you can select source, which means your phono input and also your line input, or you can flick it across then to the tape input, and independent balance control for left and right. And you can also do what we term as tone defeat. So if you just operate the switch just to the left of the volume control, what you can do then is you can just disable the tone control circuit. So that means that the bass and treble is inoperative, and you're going straight into the amplifier stages then. Now, what was the issue when this amplifier came into the workshop? Well, the customer contacted me via the YouTube channel, Lloyd Walthamstow from North East London, and said that the one output, which is the right channel output, was no longer operating and failed. But there was a lot of other issues as well. So what we'll do here is I'll just sort of go through step by step, and then we'll get to this repair of the right channel. But as often is the case, because this amplifier has been in service, probably from about sort of 2004 era, or maybe, at launch time, it just develops stock faults. And what we mean by stock faults, we just mean faults that if you had 10 of these amplifiers on the bench, you're going to find the same issues. And if you tackle these issues, when you get to the repair stage for the right channel, when you go into testing phase, you've really overcome a lot of issues which could sort of cause you additional work because it doesn't perform as it should, or you will find that you repair the fault and then you issue it back to the customer, and then the customer then says, oh, it's been running for a little while and then I've got another failure, and that failure is linked to some of these age-related issues. So the first thing that we're showing you is with the top cover removed, and this again is very, very common, and I'll mention this in many tutorials, because you have the grill on the top, which is used for ventilation purposes. Over time, of course, dust falls directly onto the circuit board, and that will also fall into some of the switches and contacts. As with previous repair tutorials, because this amplifier would be kept in a dry environment, it's very easy just to simply use the compressed air line and a brush, soft brush, just to clear out any of that dust which has fallen. It's much more difficult if it's been in a damp environment, because then what you'll find is the dust will tend to stick to the board and also impact some of the components as well. So once that was all clear, what was sort of interesting with this amplifier, and what I'm showing you next, is the real terminal connections. So these are speaker binding posts. What I could see is it's almost as if the binding posts have been chewed by maybe a puppy or something, so rather than just sort of ignore that, I just took care of that first of all. So the way in which you gain access to the board is you can remove the back panel, and then you also need to remove the fixing screws, and then you'll find underneath that there is a service plate as well. So there's quite a number of screws that you need to remove, and I'll sort of come back to the service plate later, because there is something that you need to be aware of when you're sort of in the test phase. And then all that I simply do is I just desolder the terminal binding post, and I have spare ones in stock, so easy matter to do that. What I would bring to your attention as well, these types of speaker binding posts are very similar as used with Cambridge amplifiers and maybe Rotel. So as the post comes through into the plastic part and then onto the metal contact, sometimes what you can find is if the customer has been using the binding posts and not 4mm jack plugs, they become slightly loose, and then if you try and tighten them up, they'll slightly rotate. So here, it's a good exercise also. Okay, we change over the binding post, but we can lock down those nuts to make sure that there's no intermittent contact or connection. What I would say is use a socket type set, or alternatively an adjustable spanner or fixed spanner. Try to avoid using pliers. Often with pliers, if you try and tighten it up, you can find that the pliers will slip around nuts that you're trying to tighten, and you could sort of round them off and cause damage. So far better to be using the correct tool for the job then. And then once that was complete, and I can show you here, so you can see the back of the amplifier with the new binding post. So that's a nice finish to it. The next thing to check is on the top, when you look down, I'm sort of showing you, you have these 20mm fuse holders. Now, you can find over time with all amplifiers that use these type of internal fuses that the carrier becomes loose. So either one or both ends of the fuse are not held tightly in position. And these are used, to provide power to the amplifier, or in some cases, some amplifiers use them, as part of the protection output circuit. So just remove the fuses, take a pair of pliers, and then just pinch the end so you retension them, and then you can then snap back into place the fuses. If it's an old amplifier as well, it's probably good practice to replace the fuses, because you can imagine they've been in there for decades, and I have seen cases in the past where these fuses can go resistive, and quite resistive. So you can just replace them, and then you don't have any concerns after that then. So one of these age-related issues that I spoke about, well, the first one that we're looking at now is in relation to the plus and minus 18 volt supplies. And these are, of course, critical in the operation of the amplifier. And it's always associated with this glue. And this is common. All amplifiers pretty much of this era The manufacturers use this glue to provide additional mechanical support around what they believe was more heavier components like capacitors. So you find this in amplifiers in the power supply section or sections. Some amplifiers will have multiple power supply sections, and this brown glue seems to be around the smoothing capacitors, but also it coats other components. So here we're showing that it's also making contact with the Zener Diodes, and these are the Zener Diodes in what we call the series regulator power supply. And what happens with the glue is it dries out over time, and it has two major issues. The first one, it starts to go corrosive. So if it's in contact, as it is here, with the component leads, and even the component, if you then scrape away a bit of the glue, and I would always say this, just make sure you use eye protection, because it loses all elasticity, and it almost becomes like a hard, like a lacquer. And if you try and scrape it up, I'll guarantee that it will flick up and it'll probably cause you some eye damage, or you're going to have to try and get that out. So always wear eye protection in that case. And if you just touch the component, often, as was with this case, as soon as you touched it, literally the diode fell apart. So what you have to do is sometimes you have to gain access, beyond just the glue on the board. So what I'll do is I'll remove the power supply smoothing capacitors, and I will remove all of the glue from the board and replace any components which have been contaminated by the glue. You don't have to worry too much about the electrolytics because they have a plastic coating on there. It's just a case of just scraping it off. But what I would also say is, while of course the power supply capacitors are out of circuit, then you can make an ESR check with them, and these capacitors were well within tolerance, and also ESR was very low also. So I'll show you next just an extract from the service manual, and you can see the series regulator circuit, and the Zener diodes of course are not passing through the main load current. Those are being used by the series transistors. What they're setting is the voltage output supplies. This is plus and minus 18 volts that we mentioned. So once that was then done, we then pay attention to another part of the amplifier, and this here I'm showing you, and this is another power supply section. So now this is the 29 volt power supply, and again using a typical type of circuit that you've seen a moment ago, which is this series regulator type. And in this case it hadn't covered multiple components, so there was some glue there. So again, remove the electrolytics, test them, make sure that they're good, and then clear out any of that glue. Also as well, when you remove the glue, if it's sort of flicking up a bit, just make sure you turn the amplifier over when you've completed that, and just give it a tap, and then also a brush as well. The last thing you want is any of this flaky glue to go underneath other components or in between the legs of transistors, and it will happen, trust me. And then you power up, and then you have issues that you didn't have before. So once that was all done, the next thing that I'm showing you is the input selection. Now the input selection uses an encoder, but it's actually a mechanical switch, and again this is very, very common. And the way in which you get access to it is you just pull off the input selection knob, and then located behind will be a locking nut. Once you undo that, and there's two connectors on the main board, you just lift them up, and then you can take out the multi-pin cables, and what you see is that there is a LED board, which is the one which you saw at the beginning, which illuminates to indicate which input has been selected. And then what I do is I just extract from there the input selection encoder or switch. And the next thing that I show you is that the switch has been desoldered from the board, and I do that because it's very easy once you've done that to gain access to the internal switch arrangement. And then you just take a pair of pliers, and what you have to do is just squeeze them very gently until they are straight, and then you can then extract what we call the wafer, and that contains all of the individual switch contacts. And then you just press in, and it's like a green plastic material which has the wiper of the switch on there. And then what I show you is the before. Now the before shows the original lubricating grease, which has become solidified and very hard, and then there is also some degree of oxidisation. Now you have to take care of this, and this again, as I've said, is common on all amplifiers that use this type of technology. What happens with the amp is that the microcontroller will read directly the status change of this switch, And this oxidisation and insulation from the legacy grease causes intermittent contacts. So the micro will read that as an input selection change, and it's completely random, of course. So this is the issue that customers sometimes report, where they say, well, it just changed input on its own. I didn't touch the remote and I didn't touch the fascia, and I don't know what's happening here. And sometimes if you're unfamiliar with this fault and what causes it, you could go down the avenue and think, well, maybe I've got an issue with the microcontroller, but you haven't. All right, so just take the necessary work. So what I do here is I just clean it with some Servasol Super 10 just to degrease it, and then I will use a fiberglass pencil just to clean those contacts. And as I say, now we're showing you after that it's been done. And then I just apply a little bit of De-Oxit lubricating grease onto there, just because they're mechanical contacts and they're moving, and just a slight amount of oil just onto the ball race, which is the indexing mechanism of the switch. And it's a straightforward task just to do reassemble and then to fix it back in place, and then reconnect to the board the multi-pin connectors. So once that had then been done, what we're now looking at next is a part of the amplifier for the input power. Now, during manufacture, what they do is they just make, or they produce the plastic cover. And the idea here is if someone went in there and maybe they weren't aware of that part of the circuit, it's sort of, well, it's a bit like a plug cover. You know, it prevents you from accidentally touching the power coming in where it mounts onto the board and then off then to the input switch. Yeah, well, what happens there is that this material becomes extremely brittle, almost like eggshell-like, and when you touch it, it just breaks apart. So this isn't something, you know, that you will find randomly. It's on all of these types of Rotel amplifiers that do this. So what you have to do is you have to remake one of these covers. So what I do, or what I have, is a flexible plastic, which means that you can bend it and shape it. What I do is I just cut out a pattern which is identical to what the original was, and then I just shape it, and then that's a perfect copy of what the original was. And then I take the warning label and just reattach it. So that's what we're showing here. So that's, you know, some more work which had then been done. And then the next thing that we're sort of moving on to is the right channel repair. Now, when you look from the top, there is a number of resistors that have been burnt out. Now, normally when these Rotel amplifiers fail, it tends to be in the output stage, and maybe you get the driver transistor fail. It's very uncommon, and I've not seen very many amplifiers like this, where these burnt out resistors in the earlier stages of the amplifier. So here, this wasn't a case where the output transistors failed. This means that there was a failure of a component or maybe a transistor earlier in the circuit, and then you had this cascade effect where you had the fault that took out a number of components, excess current was drawn, these resistors then became hot and then burnt out, and then the net result was that travelled through then to the output stage, and then the output transistors went short. And you can test the transistors in circuit on the heatsink, and normally you'll find that they've gone very, very low resistance, indicating that you have a short circuit and that you will need to replace them. Now, for the burnt out resistor, what I do here is once it was removed, you had some scorching on the board. So you just clear it out, and to be honest, you can just spray in like some switch contact cleaner just to scrape it out. It's a little bit like filling a tooth. Not that I'm a dentist, but same kind of procedure. And then you get it back to hard epoxy, fiberglass of the board. And then what I do is I do a quick set epoxy resin, just fill in that. And then just for cosmetics, once that was dry, I just cut out a small square of green insulation tape, and I just lay it onto the board then. So cosmetically, it almost looks identical. And then I replace, you know, the resistor. Now, it's up to yourself how you sort of approach this. What I'm showing you next is the output stage of the amplifier, and as I said, we were faced with an issue here of multiple components that failed. So for myself, you know, I tested the output stage and I was aware that the output transistors had failed, but because the issue was originally caused by, you know, earlier part failure of the circuit, I'll just change the resistors first of all, and then I'll then focus on the semiconductors and then work my way through. But you can approach this yourselves any way you wish. So what I show, as I say, is the extract from the service manual, and then what I've done is I've drawn a ring around the components which failed. So if we look at the resistors first of all, because we had a short circuit of the output stage, the emitter resistors will always fail. Now, straight away, if you look at the emitter resistors, normally on one of the failed channels, what you'll see is discoloration, and they're rated at 2 watts and they're 0.22 ohms. But I wouldn't say they're underrated, but when I tend to replace these, I will just uprate them by 1 watt to 3 watts. The resistance value will be correct, 0.22 ohms, but what I don't want to do is just sort of, run these resistors warmer than what they should be. So all 4 resistors were replaced, and then once that was done, I'd already replaced the burnt out resistor. So we're looking at R622 here, which was a 47 ohm resistor. And then you also had as well the failure of R632, R630, which are the emitters, and then there was also as well the 220 ohm resistor, which is R628, so that was replaced. And then I also point to the bias trimmer associated with the setup for the output bias setting, but always make a measurement on there. Make sure that bias trimmer hasn't burnt out. In some amplifiers it will sit there, it doesn't look damaged at all, but actually it has changed in electrical resistance because of excess current in the nature in which the stage has failed. So always check it, verify that it's okay. And when you come to do the bias, and we'll come to that in a little while, you might take the opportunity, if you are testing the bias trimmer, just to spray some De-Oxit onto the contact and just rotate it backwards and forwards multiple times, and that's just cleaning the contact and the carbon track. And then when you come to bias it, you'll find that the bias setting will be very smooth and less jittery. On some amplifiers they use a 10-turn multi-pot. Here they just use a single carbon track pot. And then what I'm showing on the tester here, so this is a transistor tester, we're showing you Q612 out of circuit, and that's a 2SC1941. And as you can see, it's not reading like a transistor at all. Here it's indicating a diode junction. But when it was first tested out and run on the transistor tester, it also measured as an FET. So the amp or the transistor hasn't failed short circuit. It's failed, leaky between the, I think it was probably the base to collector. And then the other transistors that you can see have been replaced is Q614. And then we also replaced Q616, and these are 2SD600K devices. And then we also replaced as well Q618, which is a 2SB631, and then Q612, which is the 2SC1941, which we mentioned a moment ago. So the other thing that I need to bring to your attention, and on one of the previous repair videos, and I think that it was the tutorial where we covered the Rotel RA-02, is the output transistors and which type of output transistors you're going to use. Well, the 2SB817 and the 2SD1047, if you do a general Google search looking for replacements, what you'll find is they are available and they're provided by On Semiconductor /ST Micro. But the problem is if you put these in circuit, they will not work. What you'll find is that the output stage becomes unstable, and you may well set up the bias current via the dim bulb tester. And then when you run the amplifier without the dim bulb tester, what you'll find is that the output stage starts to oscillate, and then it goes into runaway, and then it will fail. And unfortunately, it will normally take out some of the newly replaced components. What you need to source are what we call Sanyo originals. Now, be very, very careful. Many, not only myself, but other people who repair equipment and have YouTube channels will refer to the issue that you see. There are so many fake components coming in from Asia, and the marketplace is flooded. And you may go out and you sort of on these internet websites, could be auction websites, and you find devices and they, to all intents and purposes, they look like they're the original, but they're not. What they've done is they've just simply took a transistor which has the same physical mount, like TO3 type, etc., and they just skim the top off and they've just re-etched on there the part number. And in some cases they will even put onto there, so if it was maybe a Toshiba device, they'll write onto their Toshiba, so you think it's original but it isn't. The problem there is that you've done all the repair work and you're very confident that, you know, those are the only two components you need to replace, you know, to complete it. You put them in and then the whole stage fails and you're just left thinking, well, you know, what did I do wrong? You didn't do anything wrong. It just meant some unscrupulous person thought it was a good idea to sell you fake components. So here, always source Sanyo originals, and if people, you know, contact me, you know, I can advise you where to source these from. But if you do fit the originals, when you come to the alignment procedure, what you'll find is that the output stage is completely stable. And that's critically important, because the last thing you want to do is, and I'll give you an example here, to do all of the work for this amplifier, both the encoder, the power supply issues, and also repair the output stage, you're looking probably about 3 to 4 hours. I think this one topped about 4 hours because there was a lot to be done. Because not only did we replace those components, but we also replaced the speaker output relays, and there's 3 of those, just to avoid any intermittent issue with switching or loss of sound. So you don't want to invest that amount of time and the expense only to find, you know, a failure when you get to the final stage. And then to bias the amplifiers or the output stages, I said to you about this bottom plate. Now the next thing that I'm showing you is that there is a ground connection which goes from the top of the circuit board, and this is not uncommon from not only from Rotel but other manufacturers use exactly the same technique. And if you look at the service manual, which is detailed, what you'll see is that some of the components will have an earth or a grounding symbol on one end of them, and what they're showing there is that it connects to the common ground point, which is this common screw terminal point here. And some of the driver stages in the output section of the amplifier, biasing of the stages within the amplifier, resistors are connected, as we said, to a common ground point. So if you don't remake that connection, then you are changing the operation of the stage and it will not work correctly. So here, when you're in test phase, i.e. you're biasing it and then you're then testing the amplifier, you need to fix the bottom plate in place and make sure that that common ground screw is attached. As soon as you do that, of course, any connections electronically will all be back to that ground point, and then you're in the position then to do the bias. Now the bias adjustment is straightforward on this amplifier, it's not difficult. So when you look from the top of the board, what you have are these test connectors, and you can connect your multimeter to them. You might want to use some hook clips. And then I initially will run the amplifier via the gimbal tester, and for this amplifier it requires the output bias to be set to 4 millivolts. So I'll set it to about 3.5 millivolts, leave the amp running for 20 minutes just to warm through, stable environment, not drafty. And then what you have to ensure is that you don't have any speakers connected, that you have no inputs connected, and that your bass, treble and balance control are set to midpoint and your volume control is set to minimum. And then it's a simple matter, and I show this here in the video. You can see the backdrop of the multimeter where the bias has been adjusted to exactly 4 millivolts. And once you've done that, that tells you, of course, that the output stage is set up correctly. And then what I also show you is again this extract from the service manual. And what I'm highlighting here are the test connectors, as you see, TP2, and then also the bias trimmer. And because you would have done the work before, when you would have removed the bias trimmer, you wouldn't have any issue or concerns that maybe, you know, it was open circuit, which could result in damage then. Once all that was done, then the only thing really that remained was just to clean the user controls and potentiometers. So we just spray in De-Oxit into there, and we just rotate those controls backwards and forwards multiple times to ensure that they are noise free and clean in operation. And you also need to do a DC offset check on this amp as well. If there was a major DC offset, then you would find that the protection circuit would operate, but when you measure across the speaker terminals, and just make sure that you've got the speaker selection switch in the appropriate position, which connects the output stage to the respective relays internally and then to the correct terminals. Here it was probably about 6 to 7 millivolts, not higher than that. You know, if you go to the back and you sort of, you know, approaching X hundreds of millivolts, normally these will sort of trip into protection at about 500 to 600 millivolts DC offset. Here, because it was so low, no issue. But if you find that it's starting to creep up, then remember that DC offset is associated with earlier parts of the amplifier stage. So if you saw high DC offset, again, when we look at the schematic, what you need to be looking at is Q602 and Q606. So that's a 2SA1015 and a 2SA1016. Those are the transistors really that you need to replace, because they will have drifted from an HFE point of view. They're not or no longer matched, and then you'll get this DC offset, which could be plus or minus and be excessively high. Because it's associated with the gain of the amplifier, you know, this isn't going to be caused by the output stage, which is the current amplification stage of the amp. So once all of that was done, then it was a simple matter of just reassembling the amplifier completely, and then also doing what I term as a clean. But this amplifier was pretty much, you know, immaculate. Quite surprising really when you think of it, the age of it, and return them back to customer. So that sort of brings us to the end of this repair tutorial. So there's quite a lot of work, as I said, that was done, but an overall an interesting repair. And then what I would also say, often as I do with these repair tutorials, all of the work that you've seen here in this video and this part of this tutorial in the description, you can apply to other amplifiers as well. It's not unique to Rotel, and if you're in or regularly repairing amplifiers, you'll just build up this knowledge base and you can, you know, perform common practice across them. But as I always say, just take your time, okay? When you're sort of repairing electronic circuits, you know, don't try and rush it through. You know, make sure that you are, you know, doing all the necessary work. And then here as well, what I'm sort of finishing on is just the underneath of the board, and this is the solder side of the board, and just verify all solder connections. Just be aware that if these components are passing high current or are running hot, over time you may find that some of these solder joints will start to break down and then go dry jointed. So just scan the board, make sure that everything is good. And again, if you're replacing components, you could be using, for this amplifier, 6040 lead tin solder with resin flux. Just clean that off with a flux remover, and then you know, the board should be nice and clean, and that just avoids any future issues then. So I appreciate you stopping by, and if you have any questions or you need any support, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any support or guidance that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.